Hello YouTube, welcome back to another one of our videos. Today we'll be teaching you guys how to solve equations using replacement sets. So as you can see on the screen, we have the question, what is a replacement set? Many of you probably do not know what the replacement set is if you're watching this video. But even if you do and you want to increase your knowledge on replacement sets and how to use them, welcome back. So a replacement set is simply just a set of values that make an equation true. True. Okay, so that's what a replacement set is. And what do they do for us? So replacement sets, I'm just going to model a replacement set for you guys. It could look something like this. 3, 5, 8. And then suppose we have an equation that says n plus 1 equals 4. And what does n equal? In this replacement set, we can choose one of these values that would satisfy this equation. In this case, then, the value that would satisfy the equation and make it true would actually just be number 3, because 3 plus 1 equals 4, 4 equals 4, and that's true. Okay guys, so let's get some practice solving some equations using replacement sets. Okay, so for our first one, we're going to keep it super simple, and we're just going to do this. What is 3 plus n equals, you know what, it's a bit tilted, but I can draw a bit better for you guys. 3 plus n equals 8, right? And suppose we're given the given replacement set of 3, 5, 7. So most of you guys can probably, just by looking at this, just figure it out. But I want you guys to get used to doing these by hand, because at some point it's going to be really, really hard for you guys just to do these all in your head, and without any practice writing them down, it'll be very difficult. So, as you guys should have probably watched one of our old videos, it was about the properties of equality, then we could probably make this really simple for you. So, there are two ways to solve this, and I'll solve them for both ways for you guys. I'm going to solve method 1 over there, and I'll solve method number 2 over here. So the first method would just be solving this algebraically. So let's just copy down the problem over here. 3 plus n equals 8. So this is probably, in my opinion, the easier method, but you really should just have to know what you have to do. So for this, all you would do is use the subtraction property of equality and subtract 3 from both sides. And that would mean you have n equals 5, because 8 minus 3 is 5. Remember, what you do on one side, you always have to do to the other side. That's what makes it a property of equality. Now, if you didn't know how to do that, or you didn't know the properties of equality yet, or for whatever reason you just forgot about it, there's another method you guys could use to solve these. So suppose you're given this equation. 3 plus n equals 8. So first you can start plugging in values for n. So first you could plug in for the first one. So I'm going to label these values a, b, and c. So over here for value a, you can just do 3 plus n equals 8. 3 plus 3 equals 8. 6 equals 8. This is not true. So I'm going to draw an x next to it. Let's try out b. 3 plus 5 equals 8. 8 equals 8. This is in fact true. So let's just check C just in case you missed something in B. Remember, you guys, whenever you have a replacement set, you guys should always try to make sure you solve all 3 equations if you're going to solve it this way, because this is just always going to help you guys out if you miss something back in one of the other problems. So suppose you're given 3 plus n equals 8, and then 3 plus 7 equals 8, and 10 equals 8. This is obviously not true, so this is incorrect, and that makes our final answer B. Do you guys see how we got the same exact answer by doing it 2 different ways? Okay, so let's go on to a moderately more difficult problem in the form of 5x plus 3 equals 4x plus 3 plus 7. And guys, remember, whenever you're solving equations, you guys should always use PEDMAS. If you guys don't know what it stands for, you can go back to one of our previous videos. I think it was our first one, if you guys want to really watch it. And this is going to help you guys out a lot in the future. So we have PEDMAS, P-E-D-M-A-S. It stands for parentheses, exponents, division and multiplication done at the same time, addition and subtraction done at the same time. So let's start. So in this, we have 5x plus 3. If you guys watch Combine Like Terms video, you guys should know these are not like terms. You can't do anything. So this 5x plus 3 side is simplified as much as possible for now. We haven't really looked at this side yet. Now next we have multiplication. And there's a property you guys should know. It's called the distributive property of equality. Whenever we have a number multiplied by two numbers in parentheses and they're being added or subtracted or multiplied, you can just do this. You can do the number on the outside times the number 1 on the inside. So in this case, it's 4 times x is equal to 4x. And then over here, this 4 again times the second number. So, and then now we have 4 times 3 is 12. And then we're just going to carry down this addition sign. Okay, so now, just to prove to you guys, we're going to get the same exact thing. I'm going to draw a little side note that has nothing to do with the problem. And I'm going to just redo it, make sure it's straight. Draw a little side note that has nothing to do with this problem. And yeah, so suppose x was 3. So we'd have 4 times 3 plus 3. And this would be 4 times 6 equals, we don't know, so we're just going to name it x. 6 times 4 is equal to 24, so x equals 24. So even if we do it this way, and then we get x equals 3, we just get 4 times 3 plus 12 equals x. And then when we get this, we get 4 times 3 equals 12. 12 plus 12 equals x. X equals 24. So as you guys can see, x is still the same exact value, even though we're doing it in a different way. So remember, the distributive property of equality is very simple, and this is really going to help you guys out a lot when you're trying to solve some of these equations. So the distributive property of equality is one of those other properties of equality that you guys should really know. Okay, and speaking of this, I forgot to give you guys a replacement set for this. So suppose you're given, how about, let's pick up a few numbers, 14, 12, and 16. Sorry, no, how about not 12, let's just do like 8. Don't want these to be in order. So 8. So, as you guys know, we have one of two options. Option number 1 over here, option number 2 over here. So for option number 1, we're going to continue solving like this way. We distributed, and we're going to have a 7 at the end. So we're going to have 5x. Okay. First, we're going to do subtract 4x from both sides. And that would just give us x plus 3 equals 12 plus 7 is 19. Right? And then at this point, we have x plus 3 equals 19. This is a bit of a more manageable equation because if you got to sort of plug in some of these really huge numbers, at this point it will be a bit more difficult. So we can also do x plus 3 equals 19 because at this phase it would be easier. Like honestly, I feel like everyone knows at this point it's 16 plus 3 equals 19. But if you guys really just feel stumped or like something's confusing guys, or you guys are having a brain fart, you can just plug in numbers like when you add 14 plus 3 equals 19, this does not work, so this is an x. And then we have 8 plus 3 equals 19. This does not work. Oh yeah, I'm just going to name these A, B, and C. A does not work, B does not work. When we go to C, 16 plus 3 equals 19. That works, ding, ding, ding. But if you guys wanted to use the subtraction property of equality, probably be smarter. We just get x equals, subtract 3 from both sides, 16. So guys, just notice how you guys can get the same equation using the same amount of work, right? Okay, so I'm going to give you guys one more example that you guys can work on your own. It's 3, oh my god, why is everything so crooked today? Ugh. It's 3x minus 2 equals 4x times 3 squared minus 1. So guys, just remember this for this equation. So I'm just going to write it out again if you guys forgot it. So I'm going to give you guys a chance to pause the video and try to solve this equation. I will give you your replacement set literally right after you solve it, because I want you guys to try out this equation on your own first, and then I'll go through the replacement set with you. But if you guys want, you can pause it now, or in a few more seconds I'll just give you guys the replacement set so you can practice doing it both ways. Okay, so in the replacement set our values are 4, 6, and 3. Okay? That's just if you guys wanted them and you guys can pause the video yet. Okay. So hopefully at this point you have at least paused the video once. You've tried the problem out on your own, and now you're ready to conquer it with me. So we have to remember that we cannot go to approach to number 2 until we get it really simplified. Otherwise, it just makes absolutely no sense, because it'll be so much harder, right? Just learn the properties of equality, and your life will be a lot easier in Algebra 1, guys. Trust me. Coming from a guy who finished Algebra 1 just a few years ago, learning the properties of equality will really help you out. That's why I'm emphasizing it in this video series. Ugh. Let me just draw this number 1 and 2 really evenly for you guys. 1, 2, circle, circle. Okay, so we have 3x minus 2. This side cannot be reduced anymore. And we have 4x times, when we have exponent, this goes first. We don't do the multiplication, we do the exponent first, times 9 minus 1. Again, we still won't be, we can't really do much, except we really just cannot do much to the side. I want to simplify the side as much as possible first before doing anything, because you could not subtract any 4 from both sides, because we have 4 times 9, which is still bound together. So 3x minus 2 equals 9 times 4 is 36x minus 1. And then if we're going to try to isolate x, we would try to do something like, how about, we're going to subtract 3x from both sides. And then we get 33x, and so we're going to add 1 to both sides, equals negative 1. 33x equals negative 1, and then x equals negative 1/3. 1/33. Yeah. So as you can see in this equation, we can see that 4 is not a solution, 6 is not a solution, 3 is not a solution. So you guys should remember that with replacement sets, they do not always guarantee your solution, and sometimes even if you have an equation set, the equation set will not contain your solution, and in that case you can just write set does, okay, you know what, I don't know why computer's been acting up today. It's not coming up straight. Really a problem. Set is not true. So that would basically be no solution in set. Those would be two perfectly acceptable answers if you guys were to get this on an algebra test. So let's just do this now. So basically we'd have to do all these steps up till here, but if you guys want to do method 2, since we have so many huge numbers like 3 times x and then 3 squared and everything, it would just be a lot easier on all of us. If you guys wanted to use method 2, you could do it at the point where we have 33x equals negative 1, right? So then at this point, you'd still be multiplying 33 by a bunch of numbers, and that's just too much work. So this is just This example is just here to prove that using the second example will not always help you out, because even though you could plug these numbers in early on, it would just really make some huge numbers and it would get super messy and no one wants to deal with that kind of stuff. So this is not a thing that we want to do. We want to only do this when we have small numbers. But since we have some pretty big numbers in this equation, I would not recommend this. So hopefully you guys learned something in this video today. And if you did, make sure to leave a like down below and make sure to comment and subscribe. So peace guys, good luck with your algebra, and good night.